Consider the factor of steepness. On the incline, the steepness is the ratio of the change in elevation to the change in horizontal distance. This ratio, a number, is called the slope. For example, suppose the elevation of an incline increases 15 meters every 100 meters. The rider moves upward 15, horizontally 100. The slope is 0.15. A hill with a slope of 0.3 is twice as steep as one with a slope of 0.15. The bigger the slope, the steeper the hill. When the slope is large, it's no small feat to get to the top. When the slope is next to nothing, near zero, it's easy going. And when the slope is negative, it's downhill all the way at any given point. To determine the slope at a particular point, here for example, simply take another point on the hill. It doesn't matter where. Now connect the 2 points with a straight line. That line is called a chord, and its slope depends on the location of the second point. If the first and second points are reasonably close, the chord is a reasonably good approximation of the bike's path. Now, move the second point closer to the first. Move it even closer. The slope is a number, and as the points get closer together, the number gets closer to a certain value. It's reasonable to call that number the slope of the hill at that point. The line with that slope through the point is called the tangent line. And the tangent line is just what the chord turns into as the points get closer together. And the slope of the tangent line at that point is the slope of the hill. Before they actually reach zero, small numbers are marked by the Greek letter delta. Delta y is a small change in y. Delta x, a small change in x. So delta y over delta x is merely a ratio of two small numbers. When the small numbers shrink to zero, that ratio becomes a derivative, and the deltas become a new symbol, dy over dx, the symbol of the derivative, which means the derivative with respect to x of the quantity y. Once the simple mechanics are mastered, finding the derivative for just about anything is no harder than flipping a switch.
The derivative of a function is the slope of its tangent at each point. The derivative of a function is itself a function. If the function is linear, the slope is constant, and the derivative is just that constant. If y equals sine x, then dy over dx equals cosine x. If y equals cosine x, then dy over dx equals minus sine x.
Taking derivatives takes a little practice, but it's well worth the effort. That's how the sum rule works. The derivative of the sum is the sum of the derivatives. Another handy tool is the product rule.
The derivative of the product y times z is y times the derivative of z plus z times the derivative of y. Using this rule, it's possible to find the derivative of x squared. Or of x to the third power, or of any power of x.
And the value of differential calculus can be seen in the variety of its applications. For example, when a rocket moves with displacement s at time t, the derivative of the displacement is the velocity. Positive for upward motion and negative for downward motion. The derivative of the velocity is the acceleration, which is the same as taking the derivative of a derivative. That is, the second derivative of s. The acceleration is caused by the firing of the rocket.